Hello everyone, welcome back to this channel. Today we are having this equation and it reads 8 raised to power x minus 2 raised to power x all over 4 raised to power x minus 2 raised to power x equals to 70. We are asked to find x. So first thing you say is solution. So solution. We're going to write, try to bring each of the term to the same base, and the lowest base there is 2. So we have to write 8 to be 2 raised to power 3x. 8 is 2 raised to power 3 minus 2 raised to power x, that is there, all over, and 4 is 2 raised to power 2. 2 raised to power 2x minus 2 raised to power x equals to 70. Yes. And from what we are seeing 2 raised to power x, 2 raised to power x is dominant. So if we try to work in its direction, it would help us. So what if we break this up to have a term that contains 2 raised to power x, then we can factor that out and cancel it from both the numerator and the denominator. It will do us a good favor. So what do I mean? I want to say 2 raised to power x times 2 raised to power x. 2 raised to power 2s has to be 2s minus 2 raised to power x all over here 2 raised to power x is x and 2 raised to power x, that's correct, minus 2 raised to power s. Fine, let's go through it. The top is, remember, 2 raised to power 3x is the same thing as 2 raised to power s times 2 raised to power 2s. How do they become 3s? When you have a raised to power m multiplied a raised to power m, we are supposed to have a n plus m. So when it multiplies here, the right thing to say is 2 raised to power s plus 2s, which is s plus 2s is 3s. So if you break it into 2, you are still the same, you are doing the same thing. So you can go from here to here, from here to here. So we are correct if you write this way. And also, this is the right term here. And also, the same principle with which we broke down the up is what we have used down here. So the 2s becomes s, because if we add s plus s is equals to 2s. All right. So this 2s plus s is equals to 3s. Now, what did we do this for? We actually did it so that we can see that every term contains 2 raised to power s. Now we can see that there's 2 raised to power s in this term, 2 raised to power s naturally, 2 raised to power s there, and there's 2 raised to power s in 2 places. So we are here at this junction to factorize out 2 raised to power s. So 2 raised to power s, if you take away 2 raised to power s from here, to be left with 2 raised to power 2s, which is correct, minus 1. Is that right? Yes. Yes. So if you open back 2 raised to power s times 2 raised to power 2s, you have this. And 2 times 2 raised to power s times 1, you have this. Which is correct. So all over 2 raised to power s, what are you going to get? 2 raised to power s minus 1 also. Very fine. Remember it's equal to 70. Equal to 70. See? This is 70. If this is correct, what we can therefore do is to strike them out. This is over 1. If we write this, the denominator, for example, 2 raised to power s, this we have 2 raised to power s down, and then raised to power 2 minus 1 all over 2 raised to power s minus 1 equal to 17. is still also correct, because from here, if we have a raised to power m, all n equal to a raised to power m times n is cumulative. So whichever way you can come from here or here from there. So 3s times 2 is the same thing as 2 times s. So let's have a term that contains 2 raised to power s in the numerator also. So if we do this, this over 1, this is correct. So we can cross multiply. If we cross multiply, this term will multiply n to be 2 raised to power s raised to power 2 minus 1 is equal to 17 times 2 raised to power s minus 1. Let y be equal to 2 raised to power s. So that becomes y squared minus 1 equal to 17 into y minus 1. Y squared minus 1 equal to 17y minus 17. If you connect like terms, we're going to have y squared. If y comes to this side, it becomes 17y minus 17y minus 1 plus 17 equals to 0. You see? Okay, now minus 1 plus 17, that is 16. Y squared minus 17y plus 16 is equal to 0. And this obviously is a typical quadratic equation. Minus 1 times minus 16 will be positive 16. Minus 1 plus minus 16 will be definitely minus 17. So we're going to say y, the factors are minus 1 and minus 16. Fine. Y squared minus y plus 60y plus 16 equals to 0. Put in the bracket, yes. So what is common here? We have y. We take away y here from here. Have y. No y. We have y minus 1. To be left with y minus 1 minus what is common here? We have 16. You take away 16 y, and here will be minus 1. This will add on. Yeah, this is y. And the bracket is the same, so we have y minus 16 and y minus 1 equal to 0. So from here we are having y minus 16 equal to 0, or y minus 1 equal to 0. Y is equal to 16 or equal to 1. So that y is 16 or y is equal to 1. And remember, we are saying that letter y be equal to 2 over f, 2 raised to power s previously. So in the place of y, we are going to put 1 first. And this will say 1 equals to 2s. You see? Yeah. And 1 could be anything raised to power 0 is 1. If you say 2 raised to power 0 is 1, is equals to 2s. And this will say our s here is equals to 0. The first value of s is equal to 0 from there. And here, y, which is 16, is equals to 2 raised to power s. And 16 is 2 raised to power 4. And now, obviously, since the base are the same, s is definitely 4. So we got value for s to be 4 and s to be 0. So let's check this quickly. If our value satisfy the equation. So in the place of s, we're going to put 0 first. So 8 raised to power 0 minus 2 raised to the power 0 all over 4 raised to the power 0 minus 2 raised to the power 0 equals to 17. You see? So raised to the power 0 is 1 minus 1 all over 1 minus 1, definitely not equal to 17. That is to say, the value of s, that is 0, is extraneous. It's not part of the value that is applicable to this equation. That's what it means, and it's wrong. And s equals to 4. So 8 raised to the power 4 minus 2 raised to the power 4 all over 4 raised to the power 4 minus 2 raised to the power 4 equals 17. Yes. And 8 raised to the power 4 is 4096 minus 16 all over 256 minus 16 equals 17. And if you do this, you are going to have 4080 all over 240 equal to 17. 4080 divided by 240, that is 17, equal to 17. So the only value that is valid as far as the equation is concerned is when s is equal to 4. Thank you for staying tuned to this end.